Hi class, this is lesson 10.6, find segment lengths in circles. So theorem 1014 is the segment of chords theorem. It says if two chords intersect in the interior of a circle, so we've got two chords here intersecting inside a circle, then the product, so multiplying, of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So for this chord, if you multiply this segment times this segment, it equals this segment times this segment. So for our equation there, it's EA times EB equals EC times ED. So let's use theorem 1014 here. It says find ML and JK. So we know we're going to multiply this times this and set it equal to this times this. So we are going to say x times the quantity x plus 5 equals the quantity x plus 3 times the quantity x plus 1. Now we need to do a little distributing here. X times x is x squared. X times 5 is positive 5x. That equals, we're going to use FOIL over here, x times x is x squared. X times 1 is 1x. 3 times x is 3x. And x times 1 is, or 3 times 1 is 3. So let's now do a little bit of simplifying. I know these x squareds will cancel each other out. And then if I just simplify, combine my like terms here, I'm going to have 5x equals 4x plus 3. Subtract 4x from both sides. And x equals 3. So now let's look at the question though. It says find ML and JK. So ML is this entire piece. JK is this entire piece. So we need to actually find those. So to find JK, I need to do, well, this is, instead of x plus 5, it's going to be 8, because 3 plus 5 is 8. Instead of this being x, that's going to be 3. So JK equals 11. So I'm just going to add those two together. And then for ML, well, 3 plus 3 is going to be 6. And then 3 plus 1 is going to be 4. 6 plus 4 is 10. So I answered the question. The next question here says find x. So we know if I multiply this times this, it's going to equal this times this. So I can say 6 times x equals 5 times 12. Well, divide both sides by 6 to get my x alone. So x equals 5 times 12 is 60. Divided by 6 is going to be 10. And the question said to find x, which we did, so there's our answer. Down here, theorem 1015. This one says, if two secant segments share the same endpoints, we've got two secant segments here, and they're sharing the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equal the product of the lengths of the other secant segment and its external segment. So in here, EA times EB is going to equal EC times ED. So you do the little piece times the whole segment and the little piece times the whole segment. So this is EA times EB and EC times ED. Let's look at the next page. So let's use this one. We're going to find the value of x here. So we're going to do the outside segment of segment PR, so 6 times the entire segment. 6 plus 4 is 10, so 6 times 10 is going to equal the outside segment of TR, which is 5, times the entire segment is going to be x plus 5. So this is 60 equals, let's distribute 5x plus 25. If we subtract 25 from both sides, we have 5x equals 35. Divide both sides by 5, and x equals 7. The question said find the value of x, so we are all set right there. On your own 2 also says find the value of x. So for the top, we're going to do the outside times the entire segment. Now the entire segment is going to be 8 plus 6, which would be 14. So it's 6 times 14 equals, on the bottom, the outside segment times the entire thing, and the entire segment is x plus 7. So we've got 6 times 14, that's 84, equals 7x plus 49. We'll subtract 49 from both sides here. And we have 35 equals 7x. Divide both sides by 7, and x equals 5. And my question had said, find the value of x, so this is indeed my answer. One more theorem here for this lesson. It's the segments of secants and tangent theorem. So we've got a tangent here and a secant here. So if a secant segment and a tangent segment share an endpoint outside a circle, so what's happening here, then the product of the lengths of the secant segment and its external segment, so the whole thing times the outside, equals the square of the length of the tangent segment, so just this times itself. So the tangent segment squared equals the external segment times the entire segment. So let's look at our picture here. The tangent is right here. We're going to do the tangent squared equals the external times the whole thing, x plus 12. So we will say 14 squared equals my outside times my entire thing. So 14 squared is 196, and that equals x squared plus 12x. Now this is a quadratic, and there's an x squared only on one side. So in order to solve this, what we would do is we would start by moving 196 over here, because to solve most quadratics, we set it equal to 0. So I have 0 equals x squared plus 12x minus 196. From here, we'd go on and use the quadratic formula. I am not going to expect you to go that far and solve it. That's the skill you'll work on more in Algebra 2 next year. So we will stop right here for now. On your own 3, again, we are going to do the outside, just the tangent. So 8 squared equals, for the secant, the outside of the secant times the entire secant, so x plus 6. So that's 64 equals x squared plus 6x. And if we put that in standard form, by moving the 64 over, we have 0 equals x squared plus 6x minus 64. And that again brings us to the fact that it's a quadratic. You need to use a quadratic formula or some other form, maybe like factoring. And that is a skill you'll work more on in Algebra 2A. So we will stop right here for now. So this is the end of the lesson. Make sure if you have any questions, you ask me about it. And have a great day.